handout, but.
Again, we just try to use materials.
All right, so looks like fall break started early for some people. But we're going to kind of go through, I think, pretty importantly, get a pretty good base for how we're going to work through these costs. So we've already talked about where this increase in marginal costs come from, kind of stemming from this diminishing marginal returns to labor. So we'll kind of return to the labor market a little bit later on, kind of introducing that just so that we have an understanding as to why we saw those increasing marginal costs. So other than marginal costs, which, you know, we can kind of think about last class, we talked about, we're going to start thinking about things on the margin. And it was really just a change in our total cost divided by the change in quantity or output, right? However you want to define that. And so we're able to calculate these marginal costs. So we're also going to have some other costs we're interested in. So one of those would be fixed costs. So these are the things that we can't change. So these are things that maybe in the long run we could change, but in the short run, right? Things like rent on the building, we can't change that today, right? We can't move locations on a whim today. It might take a longer period of time for us to change those things. So those things that we can't change today, we're going to call, those are fixed, right? Inputs. And so they will incur us some fixed costs. So the example would be like, no matter how much I produce, right? That Chipotle example, I have to pay the rent on the building. Variable costs are going to be things that we can change in the short run. So usually we want to think about this as labor, right? There are other things we can change, potentially materials that we're using to make certain products. Maybe we can change those relatively quickly if the price of those materials goes up or down. But usually want to think about this in terms of labor. Right? So the things that can change in the short run, those costs we'll call variable costs. Right? So as we produce more, we're going to have to hire more workers, and so those variable costs will kind of change with the output that we select. If we want to produce very little, maybe even zero, our variable cost could potentially be zero. Right? But even if we produce zero, our fixed costs, right, we still had to pay those. So you almost want to think about it, if we had a function for what costs look like, my total costs would be these fixed costs plus my variable costs times quantity, right? As I increase quantity, this is going to drive up my variable costs. As I decrease quantity, potentially I can drive these all the way down to zero, right? If I produce nothing, my variable costs component is zero, but I would still have to pay those fixed costs. So we can break total cost down into two components, right? Fixed and variable costs. And we'll start to think about how those two things matter. So if I'm looking at kind of different quantities here, 0 through 7, right? Potentially I've got a fixed cost, and that will remain unchanged. It doesn't matter what quantity I choose to produce, I'm going to have to pay that same $100. So maybe this is, rent or some type of loan that I'm kind of locked into that I have to pay no matter if I produce anything this month or not. Okay. My variable costs, right? So if I was giving you kind of a visual representation, my fixed cost will just be this like horizontal line, right? Doesn't matter how much I produce, my fixed costs stay the same. But I want to think about my variable costs, right? Well, these are going to increase as I increase my output. So my variable cost might look something like this, right? They're kind of increasing as I increase up. Now, it doesn't necessarily have to be linear, right? I gave you an example here where it's not. I probably more often than not will keep it linear just to kind of make it a little bit easier in the examples that we work through, but it doesn't have to be. And then our total cost would basically be this same exact line. What would the only difference be if I was going to graph out that total cost line? At every single quantity, I would just have my variable cost plus fixed cost or plus 100, right? So basically the same line, just kind of shifted up 100. I must have, I don't know why all the numbers are right, so I'm not, this must be kind of the way it looks here, right? That difference should be 100 at every single level. You can kind of see that from here, right? At every single level quantity, the difference between total variable cost is just that same fixed cost of $100. Okay. Any questions? That shouldn't be too tough yet. Okay. So I can determine my marginal cost as well between each one of these quantities, right? So now that I have my total cost, just adding up fixed and variable costs, I can find marginal cost by the change in total cost divided by my change in quantity. Well, here, my quantity is going up by 1, so this is a kind of an easier example. I will kind of eventually move to one where potentially my quantity, if I want to increase my production, I'm not just increasing it by 1 unit, whatever the process is, it produces an additional 100 or something like that. But for now, because that change in quantity is always 1, my denominator in calculating that marginal cost is just 1. I really just have to focus on what that change in total cost is. So here, going from 0 to 1 units, my total costs went up by 70, and my output went up by 1. So 70 over 1 is 70. Then from 1 to 2, my cost go up by 50. The output went up by 1, so 50 over 1 is 50. Right? I kind of continue on with this process all the way down. Right? So we'll kind of notice about our marginal cost that initially, right, we kind of saw this dip in marginal cost. Right? As I produced more, my marginal costs were actually decreasing. So why, last class, I think we kind of had this idea that marginal cost is going to be increasing because of this diminishing returns to my labor, this diminishing marginal product of labor. So why might initially I actually see that as I produce more, my marginal costs decline? There was something we said that can happen with labor, that initially as I hire more workers, maybe it's not right away the marginal product diminishes, because initially I might get some gains from specialization. Right? So if we thought about kind of putting these on the same graph, here, I'll get to my color, just kind of highlight this difference. We could think about if I was also graphing out marginal product for different levels of output that I wanted, because I could kind of take different levels of output and determine how many workers I would need. But initially, when we're hiring more workers to create more product, maybe we saw this initial period where we saw some specialization, right? So we said, potentially, our marginal product increases initially as we want to produce more and hire more workers because of specialization. But we eventually get to a point where those gains from specializations are kind of overrun by the fact that as we hire more people, we have to go like the next most skilled, the next most skilled, the next, right? Eventually get to the point where we're hiring lower quality workers. And so we get this diminishing kind of returns to labor. So that diminishing returns to labor caused marginal costs to be increasing. So when we had that area of specialization where marginal product of labor was increasing, that would actually be driving down our marginal costs. So these two things are, marginal costs of production are directly related to how productive our labor force is. So we can kind of see that play out in the numbers here, where initially we see marginal costs kind of decreasing, right, as we produce more. But then eventually we exhaust those gains from specialization and pass the quantity of what looks like 3 here. Past that quantity of 3, our marginal costs are increasing. Questions on that? All right, so we've talked about and kind of walked through how we calculate these marginal costs, and potentially we see initially that they're falling because of this specialization, but eventually they begin to increase because we have that diminishing returns to labor. Okay. So we kind of already went through all these bullet points with that kind of drawn on the board. I think that kind of helps connect those two things. So if I graphed out my marginal cost here, it looks something like this. I already have it drawn very similar to the board, but if we use the actual values here, we can see that for the first few units, it's decreasing and then kind of increases past that point. So how does this relate to kind of fixed and variable costs, right? So if we think about marginal costs, those are the change in cost from producing one more unit. But those vary across every single unit, right? The marginal cost of the first unit is the same as the second or the third or the fourth. we talked a little bit last week about, last class, about when we're thinking about averages. We said that as long as the marginal cost was above kind of average costs, that we're adding a value that's above the average, that would bring the new average up higher. Right? If the marginal cost was ever below our average cost, well, now we're adding values that are lower than the average, so our new average would be lower. We're going to kind of see how that plays out here in just a second, but before we kind of get to total cost, let's look at each individual cost. Right? So we're not going to just look at average total cost first, we'll break it down into components. So my average fixed cost here, as I produce more, what's going to happen to my average fixed cost? So average fixed cost, anytime we're finding an average, we're just going to take the total fixed costs, or the total of whatever we're trying to find the average of, and divide it by quantity. Well, what's true about my fixed costs? They don't change as my quantity changes. So as I produce more and more, what's going to happen to my average total cost, or average fixed costs? Yeah, I just keep dividing it by a larger and larger number. So kind of starts out for that first unit, right? The average just is whatever the fixed cost is, right? I'm just taking that number divided by 1. And then as I produce more and more, I'm kind of spreading out that fixed cost across more units, right? If I'm paying this $1,000 in rent on a building and I only produce 1 unit, well, I've only kind of spread that cost out over 1 unit, right? So my average fixed cost is going to be 1,000. But if I can produce 1,000 units, well, then that fixed cost of 1,000, each unit is kind of absorbing just $1 of that, right? So my average fixed cost there would be $1,000 for rent divided by $1,000 or 1,000 units I'm producing. I end up with an average fixed cost of $1. Right? So as I produce more, I'm driving that average fixed cost down lower and lower. Yeah, I think this is the way to think about it. Right? As I produce more and more, I'm spreading those costs out over more and more units, at least those fixed costs. Any questions on this? Does this make sense? Or any confusion on this? This one shouldn't be too bad. What if, okay, so yeah, so if we graph, well, we can kind of see, right? We're kind of decreasing as we produce more. A nice little visual. It's a little bit more interesting are our average variable costs. Right? So our average variable costs, right, would simply then be whatever our total variable costs are divided by how much we produce. The interesting thing is those variable costs we know are going to change as we produce more and more. So initially, right, my variable costs, right, may be decreasing because of this gains from specialization. So I'm thinking about, got the equation there. So I'm thinking about my average variable costs. Notice initially they're decreasing, right, going from like 70 to 52 as I produce more and more units. And that's the idea that, yes, to produce more, I have to hire more workers. But because of this gains from specialization, as I hire more workers to produce a higher level of output, I'm starting to get these gains from specialization, and my workers start to become more and more productive initially as I hire more of them, because they can start specializing in their own job. Eventually, I get to a point, though, where that marginal product starts to decline. And then as I want to produce more, that's going to mean that my marginal costs are rising. Well, eventually there's going to get to be a point where my marginal costs are greater than my average variable costs. So if my marginal cost, the amount of cost I'm adding by producing more, is a greater value than my average, well, my new average will then be a little bit higher. And if the marginal cost is greater than that average, well, now my new average will be a little bit higher. I'm just adding now numbers that were greater than whatever my old average was. So eventually I get to a point where my average variable costs are no longer declining because I've exhausted those gains from specialization, and they begin to increase. Is that clear as to why that would be. So if we think about it initially, I'm going to have these costs. Right? The very first unit, whatever my marginal cost is, that would just be my average variable cost as well, right? Because it's the change in costs, so it's the part of cost that's variable. And I'm only producing one unit, so maybe it's something like, if I want to produce that first unit, my marginal cost, average variable cost, we'll kind of keep this simple in here. Maybe the marginal cost in that first unit is 10, which means the average variable cost is 10 over 1 or 10. Right? So the marginal cost and average variable cost for that first unit start at the same point. Then for the second unit, notice, well, maybe going from the first to the second unit, my marginal costs are falling a little bit. So notice this marginal cost value is lower than my old average. So what should be true about my new average variable cost? It should be a little bit lower. So here, if I'm thinking about my average variable cost, well, what's my total variable costs? Well, for the first worker, I would have it was 10. Second worker, first unit of output was 10. Second unit of output was 8. So my total cost was 18. Divided by 2 units, sure enough, my new average is lower. And then if I go to that third worker, maybe, or that third unit of output, right? I hire another worker to produce more output. Well, this time my marginal cost is even lower because maybe I get down to this point, right? I'm on that cost curve to the point where they're as low as I get. Now, if I add up my total variable costs here, I've got what, 24 divided by 3. Notice my marginal cost was lower than my old average, so my new average ends up being a little bit lower. I'll do one more and show you. What if we wanted a fourth unit of output? And I'm going to do a crazy jump. So I'm going to do maybe that fourth unit, my marginal cost has started to get on that increasing part of the cost curve. Now my marginal costs are up to 10. What's my total variable cost? 10 plus 8 plus 6 plus 10. So I've got what? 34 there. Divided by 4. So I'd be at what? 8.5, I think. Is that right? 32. Yeah. So now notice my marginal cost was above the average. So my new average is going to be a little bit higher. So it ends up being true. I think I've got a nice visual here. Otherwise, I'll draw it on the board. So we've got our average variable cost curve. Because I'm drawing this on the board. So my average variable cost curve, what's going to be true is, and I know I have this in some people's stuff, but I want to make sure I mention it here. So our average variable cost curves, right? But initially those variable costs were declining, and then eventually they began to increase, right? I saw that play out in the numbers. Right? Initially they're falling, and then eventually they start to increase. What ends up being true try to draw this to scale. My marginal costs, although they're initially declining, so initially they actually kind of start, I said, at the same point, right? Initially, my average variable and my marginal cost, that first unit were the same value. Well, then as my marginal costs start to decline because of specialization, right, from my workers, I'm now adding lower and lower marginal cost values that are lower than my average. So my new average continues to be lower and lower. And we saw that play out here in the numbers. At a certain point, right, the marginal cost will be exactly equal to my average variable cost. Because if this average is declining, but then all of a sudden my marginal costs start to increase, right, past the point of specialization, eventually they're going to increase to where they're above that average, right? The marginal cost of adding that additional unit, so the additional cost that I'm adding, is above my old average variable cost. So as soon as it starts to get above the old average, right? Once we had marginal costs that were above the old average, what started happening to average variable costs? And my new average was a little bit higher. So at every point here where my marginal cost is above the old average, notice the average variable cost curve is increasing. So the point at which this marginal cost intersects the average variable cost will be at the lowest possible point for average variable costs. At any point past that, well, we're just adding additional costs that were above the old average, so our new average is just going to be getting higher and higher, right? Or average variable cost curve will then be increasing. Questions on that? Yeah. Yeah, so the point at which the marginal cost curve intersects my average variable cost curve, that reflects the quantity where my marginal cost would have been exactly equal to the average. So think about it there, I'm adding the same value to my new average, my average won't change. So that's the point where those two things are the same. That'll actually be at the lowest possible point on my average variable cost. Because now, any point past that, once they were equal to each other, because I know that as I produce more, marginal costs are increasing, my new marginal cost, if I produce one more unit from this point, has to have a value that's above the old average. As soon as I start adding marginal costs that were above that old average, the new average has to be increasing. So past this point, I know average variable costs are always going to be increasing. So that was the minimum point of average variable cost. Is that what you were asking about at that point? Any other questions? So we can kind of build out this all in one table, right? I could look at my total costs, and I could also find my average total costs, right? How would I do that? Well, I just take those total costs and divide by the quantity, just like what we were doing before. So I'll go through, take every total cost, divide it by quantity, and I can produce my average total cost here. I could then throw in kind of the old average fixed and variable costs that I found. So, if you notice, right, my average total costs are the sum of my average fixed and my average variable costs. So why is that the case? Well, if I think about that equation I had, where total costs are my fixed costs, we'll call this kind of total variable costs. I guess if we really wanted to, we would call this total fixed cost, but fixed costs don't change, so the total is always the same. So it's kind of semantics there. If I want to find average total costs, all I do is divide this by the quantity that I'm producing. But then to find the average total, I would have, I'm dividing this by Q, I have to divide this by Q as well to make sure that equation, that equality holds. So what I've really just got here is that my average total cost is equal to total fixed cost divided by quantity was average fixed costs. Total variable cost divided by quantity was average variable costs. So that's the mathematics plays that shows us why my average total cost will just be the sum of my average fixed and my average variable. So that's why if we look at this table, even if I didn't have this column, I didn't have the average total cost column here, and maybe I don't have the total cost either, so I can't calculate it by taking the total cost divided by quantity. I could just add up my average total, my average fixed and my average variable costs at each quantity to reproduce those average totals. Maybe it's easier to see here. At 56 plus 20 is 76, 52.5 plus 25 is 77.5, so on and so forth. So there's multiple ways that we could find the total cost there, depending on which components maybe we're missing. Questions on that? So we have a very similar thing. Now, this isn't overly important, but so I will show on the next slide, but I'll take time to show you. So if we've got average total costs, they tend to follow a similar pattern as average variable costs. The only difference is, right? Excuse me. Average variable costs kind of have this shape, where our average fixed costs we're being driven down to zero. Think about it this way. If my fixed costs were $1,000, but I'm producing 1,000,000 units, my average fixed costs are like pretty much zero, right? I'm driving them down to zero. I'm spreading those fixed costs out on across a lot of different units. So really, the shape of our average total cost curve is really going to be dictated by that average variable cost. Now, it will be different, right? It will be a little higher. At every quantity, my average total cost will be that average variable costs plus whatever the average fixed costs are. So if I'm thinking about the relationship of average total and average variable cost, it's going to be true that the average variable cost curve will always be a little bit lower than my average total cost curve. And the difference between those would just be whatever my average fixed cost was. The only difference between average total and average variable costs are these average variable fixed costs, right? That's what I'm adding to. So you got to think about initially, because my average fixed costs are going to start out high and then kind of be driven down to zero. Initially, the low quantities, this value will be relatively high. So the difference between my average total and my average variable costs, maybe when I'm producing a quantity of 1, my average fixed cost is still 100. So maybe the gap or the distance in between those two curves will be pretty wide. As I produce more and more, I'm driving my average fixed costs down to zero. So maybe once I get up to like this 7th unit, now my average fixed costs are only 25. Well, now the gap in between my average total and average variable costs is going to be much smaller. So notice here at low quantities, the difference between this blue and green line, my average variable and average total cost, is pretty big. As I produce more and more, that gap starts to get smaller and smaller, right? And that's because the gap in between those two is really just coming from this average fixed cost. And fixed costs stay the same, so as I produce more and more, the average fixed cost gets driven down to zero. I'm just spreading that cost out across more and more units. So that's kind of the relationship of all these. Now I can throw in one more cost curve, which is this marginal cost curve. Now what's going to end up being true is, and it's really the same logic, right? Is that my average total costs and I try to draw this to scale. I think it's better. I'll have it better on the screen in a second. But it will also intersect, so my marginal cost curve will intersect my average total cost at the minimum point of my average total cost curve as well. So the point where marginal cost intersects the average variable and average total cost curves will be at their minimum point. And it's the same idea. If my marginal cost is below the old average, well, my new average is going to be a little bit lower. If marginal costs are above my old average, my new average is going to be getting higher and higher. It's the same sort of logic that applies. So it looks something like this, right? Where it's kind of intersecting these two things at their minimum point, right? The average total cost and the average variable cost curve. And marginal cost will intersect those two at their minimum point. Okay. So that would be a pretty good drawing to have there. Taking notes. So we've got all these costs. Right? We want to better understand these costs. Oh yeah, you can always remember that marginal cost, if you're drawing it out, kind of looks like a Nike sign, right? Initially kind of dips and then swings up real quick where we see increasing marginal costs. So we've got all these equations, right? But they're not too terribly tough, you know? All we're doing is finding averages here. And the average just means take whatever you're interested in, whether or not that's total cost, fixed cost, or variable costs. I just divide that by how much you're producing. Total costs will just be composed of two components, total fixed and total variable costs. And I already showed you kind of to turn those into averages, right? That's the equation would hold if we just divide everything by Q. And then the only other thing we really have to worry about is we can determine marginal costs by taking the change in costs divided by the change in output. So. I don't know why I put different color things on. So let's start to think about, can we fill this out? Right? So I think I have here that will take 5 minutes to use that kind of work with each other. But we will kind of work on this together. And I'm not going to do any of it. I'm going to rely on you guys. So I'll start to fill in parts of this table as kind of people find things. So start working on this with people around you. Start to think about how could I find different parts of this table. So I've got different quantities, and I have a couple of the pieces filled in, right? So maybe it's going to be something like this. If I know that the average fixed cost is equal to my total fixed cost over quantity, even if I'm not given the total fixed cost, but I'm told what the average is. So maybe it was something like 5 is equal to. So maybe I can see that at the second quantity, my average fixed costs are 5. So if I know that, I can determine what my total fixed costs are by just doing a little bit of algebra, right? Multiply each side by 2, and I can figure out my total fixed cost there would be what, 10? So you might have a little bit of algebra to do, but given this information, you can actually fill out this entire table. So start to work on this with people around you, kind of talk through this, try to figure out what pieces of the table you can come up with, and then after a couple minutes, we'll kind of start filling it in together. Okay? I'm gonna write this up here as you guys kind of work. All right. So you can keep working, kind of talk through this. I apologize for my unstraight line, but this is the best I can do. So we got 4 different quantities, well, 5 quantities of count 0. So let's just start figuring out what kind of the easy function. So at a quantity of 0, what are our only costs? Our only cost would be fixed costs, right? So if I'm thinking about my total cost, that's fixed costs plus variable costs. Or here, I think I wrote this as total fixed costs and total variable costs, but same idea. So at the quantity of 0, I know that my total variable cost should be 0. Right? My variable costs were the ones that were tied to how much I was producing. So my total variable cost at a quantity of 0 should just be 0. So what would my fixed cost be? My total fixed cost. Yeah, right. If my total cost is the sum of my fixed costs and my variable costs, but at a quantity of 0, I know that I have no variable costs. My variable costs were the costs that change when I produce more. Right? So my variable costs at 0 are nothing. I'm not producing anything. I don't have to hire any workers, right? I don't have to do anything. So I know that my total fixed costs will be 720. So what else can I fill in now? Yeah, I saw someone just go like this, right? I know that at every single quantity, my fixed costs haven't changed at all. Right? So I've got this entire column, right? Where I've identified my fixed costs. From here, it probably starts to get a little bit trickier about kind of how I can in fact figure out what what pieces I can fill in. But anytime I have kind of 2 known pieces of information in the same quantity, I can probably solve for something else. Are there any questions what we've done up to this point? Yeah.
So it's 0 for the total variable cost because the quantity is 0.
Yeah, so think about it like variable costs. If this is the easiest way to do it, it isn't like in every case, but in the short run, usually like the only thing that can really change is labor, right? So the costs that are going to be changing as I want to produce more or less are coming from hiring fewer or more workers. But if I'm producing nothing, I don't have to hire anybody. I mean, I don't have, I have enough, I'm down to 0 people. Well, then my variable costs are 0. Now, I might still have a bunch of fixed costs. I might have this huge factory with all this machinery, and maybe all these loans I've accrued that I still have to pay. But in terms of the cost that I can change in the moment, in the short run, my workers, those are 0. I'm hiring nobody if I'm producing nothing. Or at least that should be. I don't know why I'd be paying someone to just sit around when I'm not making any products. So that's why we know our total variable cost at a quantity of 0 will always be 0. So our only costs that we actually have are these fixed costs. And the total fixed costs don't change no matter how much I do. So with this information, I can actually go ahead and fill in another column as well. So I can fill in potentially different rows. There's actually an entire column I can fill out. Yeah, right. If I know the fixed costs, right, are the same at every quantity, well, I can find the new averages. So I've got what, 720 over 1. So this is just 720. 720 divided by 2. So 720 divided by 2, get what? 360. 720 divided by 3. That goes to like 240. And then 720 divided by 4. Yeah. 180. 180, right? So I can fill in that entire column. From here, let's start to think about, is there anything else that I can kind of figure out? So let's look where we have a row where we have the most information. That might be the easiest. So if I'm looking down here, and I know that I've got fixed costs, I've got marginal costs, doesn't, usually these fixed costs don't help me find a whole lot more. So let's find a row where we have more than just the fixed costs, we've got two other things. So I look here. Well, I've got total costs and total fixed costs here, as well as the average fixed cost. So if my total costs are 740, and my total fixed costs are 720, what's something maybe I could fill in this row? My variable costs, because I know that my variable cost plus my fixed costs should be equal to the total, right? So I've got my total variable costs plus 720 should just be equal to that 740. Just plugging values in here, kind of, now I just have to solve for this thing I don't know. I do a little bit of algebra, or I think with these ones, it's easy enough to see that total variable cost is going to be 20. Okay, so then my average variable costs will be what? Average, I just take the total and divide it by the quantity, so 20 over 2 to 10. Okay, so here's another line, maybe I can figure something else. So I've got an average variable cost here.
This is your average total cost.
Oh, I could do my average total as well, right? So I can go here, I forgot about this column. So we can take my average total cost of 740, divided by that quantity of 2. What's that, 365? No, 370. So what about the marginal cost there? Well, to get marginal cost, we would have to know what the total cost was in the line before. We don't know that yet, right? So we'll kind of keep working on this. So if I've got my average variable costs, right, I can back out. I know average variable costs on my total variable costs over quantity. So if I know my average variable costs are 15, and I know that it's at that quantity of 3, well, now it's just a little bit of algebra to solve what those total variable costs are. So I multiply both sides by 3, and I get my total variable cost there would be what? 45. So here, total variable costs are 45. Which then I can fill in my total cost, right? I've got total variable, I've got total fixed. I'll just add those together. I get my new total cost of that quantity. Yeah.
Variable cost. Second row.
Oh, right here. Thank you. I was looking at that thinking, how are we going to do this? I think we might have a problem. Okay, so now if we have this total variable cost, what's my total cost of the quantity of 1? Once again, total costs are just total variable plus total fixed. Right here. Yeah, so my average variable costs are just take my total variable cost divided by the quantity. So if I have a quantity of 1, it makes it pretty easy. 7 over 1. I've got an average variable cost of 1. Or 7, not 1. That would, sorry. Right, 7 over 1 is 7. Okay. So I can fill in one more thing on that line because I now have my total cost. What's my average total cost? 727 for my total cost divided by the quantity of 1. It's not 1, it's 727. So I've got a lot of this filled in now. It looks like there's probably one down here I can find. Average total cost. I would just take my total cost divided by the quantity. So 765 divided by 3. Which would be 255, right? We've got this last line. Right? So this one's a little bit tricky. Because all I have are my fixed and my average fixed costs. I don't have any total or any variable costs. But I know, sorry, I do have one. My average total cost is 202. So if I know my average total cost is 202, what's something else I could find easier?
Total cost.
Yeah, similar idea to what we're doing here, right? I could take my average total cost equation, plug in the components I know. So if I know my average total cost is equal to total cost over quantity. So I'm at a quantity of 4. I know my average cost is 202. So if I rearrange a little bit, multiply both sides by 4, I get that my total costs are equal to 808. Right? So I can fill in my total cost down here. Now that I know my total cost, what else? Yeah, total variable, right? Because I know variable plus fixed will give me that total. So if I'm looking at this here, I could write out the equation. I can kind of see the difference between those two is 88. And then now that I have variable cost, I can find my average variable cost by simply dividing that by the quantity. So what, 88 over 4, what, 22? So we've got every single thing filled in now, I think, except for marginal cost. So how can I determine marginal cost? That's just my change in cost, total cost to be more specific, from a change in quantity. Well, here I've got changes in quantity of 1. So all I'm really going to do is go through and see how much the total cost changes. A change in total cost and a change in quantity. So here my marginal costs. And the total cost was 7. Change in my total costs 13. Change in my total costs 5. And change in total cost down here to what? 35, 40, 43. So now basically filled in this entire. Any questions over any of those? So, this is really, I think it's helpful for you guys to work through it. Right? You have the actual values here, right? It's really getting used to using those average equations, knowing the fact that your total costs are just the sum of fixed and variable, and then also kind of getting real familiar with this definition of the marginal cost, which is just the change in total cost divided by the change in quantity. So, where are we at in time? A couple minutes. So one thing that we kind of already talked about, but I'll just kind of end this on this so we won't have to revisit it, is that, if I can get here, there we go. We've already kind of really hammered this idea, I think, of any time our marginal cost is below the average total cost, we're adding costs that are lower than what we have in the past, right? So this value that is lower than the old average will mean that the new average has to be even lower, right? It's pulling that average down. So anytime the marginal cost curve is below average total costs are decreasing. Once marginal costs start to get greater than the average total cost, now my average total cost will be increasing because I'm adding a value that's above the average, so the new average is going to pull up even higher. So kind of that rule, we kind of have right here, that relationship between marginal cost and average total cost tells us about whether or not average total cost is falling or whether it's rising, right? So anytime the marginal cost is below the average, it'll be decreasing or it's kind of falling. Anytime the marginal cost is above the average will be increasing. And you can look at these numbers and we could kind of actually see that it plays out in the numbers as well. But here, kind of, I think this is a nice, real nice visual representation of that. So I won't necessarily ask you this question, but for those of you guys who show up today, since you didn't take an early fall break, oh, I had it here. There we go. On your way out, just kind of respond with whatever letter you're feeling like today. Give me 1 second. I think it's still pulling open. Where did it go? Here it is. So you can answer with anyone. I'm just trying to get you recorded for that you were here today. And you participated, kind of trying to go through this table with me. So that homework is up there on Canvas. If you want to work through that over fall break, you can. Other than that, we'll meet again on Wednesday. So try to decompress a little bit, enjoy your fall break. We'll reconvene next Wednesday. Oh, thank you. Yeah, and if you have corrections, you want to turn it on your way out, feel free to do that. Oh, yeah, no problem. Yeah, you too. Oh, give me one. I got you. Kayla, right?
Yep.
Sorry, I couldn't give it to him. It's not, we're not supposed to ever share grades or anything.
No,
with
you're
students,
good,
so, yeah.
Thank you.
Yep.
Oh,